Hey guys, so we'll talk about double angle, half angle, and reduction formulas today. All of these are double angle. The double angles come straight from the sum and difference formulas that we looked at in the last lesson. So these ones come from the sum and difference formulas. The half angles come from the double angle formulas, and the reduction formulas also, surprisingly, come from the double angle formulas. So these are things you can add to your note card, the double angle formulas. I'm going to show you on the next slide how these double angle formulas come from the sum and difference formulas. So let's look at this example. This is the double angle formula for sine. It's the same thing as 2 sine theta cosine theta. Just as you see here, 2 sine theta cosine theta. The one for cosine is expressed three ways because I'll explain that in a bit. The three different ways you can write it. And the one for tangent is just this one. So something that I would like you to do on your own is go back to the sum and difference formulas. If you go to the sum formula for, let's start with sine. Sine, you remember, x plus y was the same as sine of x cosine of y plus cosine of x sine of y. That was the formula for the sum for sine. Now think about what happens if x is equal to y. If x and y are the same angle, then you'd basically have sine of x plus x because x is equal to y. And sine of x plus x can just be written as sine of 2x. So if I got here and substitute for y as x, instead of y, I substitute for x, what I end up with is sine of x cosine of x instead of cosine of y plus cosine of x sine of x. If you look at it critically, these are the same expressions. This is sine x cosine x. This is cosine x sine x. Same expressions, just different order. And since it's multiplication, we know they are the same thing. And if you have the same thing, like a plus a, then that's basically 2a, 2 of the same thing. So I have 2 of the same thing, 2 of sine of x cosine of x. That's why the double angle basically means that the angle is doubled. So the angle is doubled, it's twice the angle, is 2 sine x, 2 sine theta cosine theta, or 2 sine x cosine x. One interesting thing that you're going to notice about these double angle formulas is that operations can be done on the angle. What I mean is, if I multiply the angle by 2 here, then I have to multiply the angle by 2 on the side, and the expression will remain consistent. And you can test this on your calculator. So for example, if I have sine of 4x, I've basically multiplied this angle by 2 to get 4x. I've multiplied the angle by 2. If I have sine of 4x, it will be the same thing as 2 sine, multiply the angle by 2, so 2x, cosine, multiply the angle by 2, so 2x, right? And this works. Like I said, you can test on your calculator. This works even if I multiply the angle by 5 over 2, right? Then this initial one is the one I multiplied by 5 over 2 will become sine 5x out of 4, right? And to the right I'll have 2 sine, instead of x, it will just become 5x out of 2, cosine 5x out of 2. So I'm just trying to stress that operations on the angle are possible for these expressions. But for now, what you need to remember is that the double angle expression for sine is just 2 sine of x cosine of x. Yeah, 2 sine of x cosine of x. The one for cosine, again going back to the addition formula for cosine, cosine of x plus y, I hope you remember from last lesson, was cosine of x times cosine of y minus sine of x times sine of y. Now if I make, if x is equal to y, if x and y are the same thing, then this will be cosine 2x, and this will become cosine of x times sine of, instead of x, instead of y, x, minus sine of x times sine of, instead of y, x, 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 x. So you end up with cosine squared x minus sine squared x, because cosine times cosine, it's supposed to be cosine, sorry, because cosine times cosine is cosine squared, and sine times sine is sine squared x. Now the reason why the double angle formula for cosine can be written in three different ways is because I can express the cosine as sine, and I can express the sine as cosine. So the other way I can write it is if I decide to express the cosine as a sine. If I express the cosine as a sine, I know cosine is the same thing as 1 minus sine squared x. But there's also another sine squared x already. So if I combine these two, it's basically 1 minus 2 sine squared x. Because you have this sine squared x that's negative, and this sine squared x that's negative, and together they combine to give you 2 negative sine squared x's. It's just two of the same thing. A third way that I can write it is if I express this sine as a cosine, right? Instead of expressing cosine as sine, I'll express sine as a cosine. So it's still cosine of 2x is equal to cosine squared x remains, but instead of this sine squared x, I'm going to express this sine squared x as a cosine, and I know that that is 1 minus cosine squared of x. Now when the negative goes inside, this will be negative 1, but this will be positive cosine squared x. So the whole thing is cosine squared x minus 1 plus another cosine squared x. These are two of the same thing, so I can add them, and I have 2 of the same thing, cosine squared x minus 1. So that's why the double angle for cosine is written in three different ways, and each of these ways will help you depending on the circumstances. Like I said, add them to your note card. When you have them on your note card, it probably will be easier for you to figure out which one you can use. The last one, for tangent of 2 theta, going back to what it was. Remember, tangent x plus y was tan of x plus tan of y divided by 1 minus tan x tan y. This is from the sum formula for tan. Now if x is y, if y is equal to x, then this whole thing will be tangent of 2x is equal to tan of x. Instead of tan of y, I'll have tan of x. Instead of 1 minus tan x tan y, I'll have 1 minus tan x tan x. On the top I have two of the same things, so 2 tan x, and at the bottom I have tan x times tan x. Tan x times tan x is the same thing as tan squared x, so tan squared x. So that's the double angle identity or formula for tan of 2x. Now, obviously you didn't need to know any of this. You guys just need to know the formulas and use them. But it helped me as a student when I was your age to know where they came from. And that helped me appreciate them and apply them easier or better. If it helps you, good. If it doesn't, just go ahead and use your note card to make the substitutions. So use the angle sum formula to prove sine 2 theta is equal to 2 sine theta cosine theta. Well, we already did that. I think that's the first one we did. We did that here. Yeah, we did that here. So this is what you're writing for that part. That is what you're writing. Yeah. because when sine x plus y, or x plus y, if x is equal to y, then you just replace for y as x, and then it will come up as 2 of the same thing. So we can put a check on this one. Alright. Now there's something else called the half angle formulas. Interesting stuff. You can go ahead and write this on your note card. The positive or negative is determined by the quadrant of the angle theta over 2. So these half angle formulas, although they look interesting, they actually come from the double angle formulas. And they come from the double angle formula for cosine. That's where we get them from. Because remember, the one for cosine could be written 3 different ways. One of them was cosine of 2 theta was 2 cosine squared theta minus 1. Another way of writing it was cosine of 2 theta was 1 minus 2 sine squared theta. Now, I told you that operations can be done to these angles. So I can do something to this angle. I can divide this angle by 2. I can divide this angle by 10. I can multiply the angle by 12, by 50, by 60. So what happens when I divide the angle by 2 on both sides, and whatever I do, I have to do it both sides. And please remember, it is only the angle that I am doing this operation on. When I do the operation on the angle, the equation or the identity remains consistent. When I divide this angle by 2, on the left I'll be left with just cosine of theta, and then on the right I have this beautiful cosine squared theta over 2. This here is what we call the half angle, right? Because the angle has been halved, half angle. And the half angle formulas are basically an expression of an expression of this. So if I try to make cosine of theta over 2 the subject, let's see what happens. I want to make cosine theta over 2 the subject, so I'm going to add 1 to both sides. Add 1 to both sides, and I end up with 2 cosine squared theta over 2, because it's halved, is equal to 1 plus cosine theta. I wrote this on the left and then the other things on the right. Same thing though. If it's confusing, let me do it the way you expect. So I added 1 to the side, so I have 1 plus cosine theta is equal to 2 cosine squared theta over 2. Remember, I want to solve for cos theta over 2, so I'm going to divide both sides by 2. Divide both sides by 2. I end up with 1 plus cosine theta over 2 is equal to cosine squared theta over 2. Since I'm only interested in cos theta over 2, I'll take square roots, both sides. The square will cancel the square root, and I end up with cosine theta over 2. The half angle formula for cosine is 1 plus cosine theta over 2, which is what you see over here, this one, right? So I can follow the same process to get the one for sine. I'm just going to do this quickly. Divide the angle by 2, make sine the subject, so this is 2 sine squared theta over 2 equals 1 minus cosine 2 theta, divide both sides by 2, sine squared theta over 2 is equal to 1 minus cosine theta, all divided by 2, take square root to both sides. So the half angle formula for sine of theta over 2 is the same as 1 minus cosine theta divided by 2, all under square root, plus minus, don't forget plus minus. So these are the ones you see over here. Yeah, and the one for tan, I know that tan of theta is basically sine of theta divided by cosine of theta. If I divide the angle by 2 in all cases, right, then I can substitute the half angle formulas for sine and cosine. I can substitute the one for sine, and I can substitute the one for cosine. So the one for sine is 1 minus cosine theta over 2 square root, and the one for cosine is 1 plus cosine theta over 2 square root. And when I simplify this, it's going to simplify to 1 minus cosine theta divided by 1 plus cosine theta, all under square root plus minus. So that's the double angle formula for tan. I'm just showing you how they come about, and we can go ahead and apply them. Okay, application. What's the exact value of cosine 22.5? I hope you can see that 22.5 is half of 45. So 45 over 2 is the same as 22.5. I'm just going to use this formula. I'm going to use this formula, the half angle formula for cosine. So according to this half angle formula, my theta is whatever is on top. So my theta is going to be 45 degrees. My theta is 45 degrees. So I'm going to substitute 1 plus, it says 1 plus cosine of theta, so cosine of 45, all divided by 2, take square root. Cosine of 45 is root 2 divided by 2. Check what with 5, 1, all divided by 2. So from here, the only thing that I need to do is simplify. Simplifying, I have 2 plus root 2 over 2, so it's basically 2 plus root 2 divided by 4, all under square root. What did I do? I did LCM, 2 plus root 2 over 2 over 2 square root, and then I did 2 plus root 2 over 2 times 1 over 2 square root. That's how I got the 4. That's how I got this 4. And this can simplify to 2 plus root 2 over 2. Okay. 2 plus square root of 2 plus root 2 divided by 2. And again, the step that I skipped is square root of the top divided by square root of the bottom. And since square root of the bottom is 2, that's why I have that 2. Okay, still from the double angle formulas, we have what we call the reduction formulas. Reduction formulas means that if I have a high power of a sine or cosine or tangent function, I can express it in terms of the double angle formula for cosine. Now, again, you can just go to the double angle formula for cosine and make sine the subject. This is what you'll come up with. So basically, the reduction formulas are, like I said, operations can be done to these angles. The reduction formulas are different ways of restating the double angle formula for cosine, but they have been called reduction formulas specifically so that you can apply them directly without having to go through making each of them the subject each time. So write them on your note card, then let's start using them. I have sine to the power 4 8x. Obviously, this I'm going to use the reduction formula for sine, right? Sine squared of x will be 1 minus cosine x divided by 2. Now, 8 sine to the power 4 is the same thing as sine squared 8x to the power 2, correct? So sine squared 8x alone, what's inside the bracket? Since the formula I'm using is sine squared of x is 1 minus cos 2x, 1 minus cosine 2x over 2. This is the formula that I am using. So I hope you can see that in this case, the angle here, the multiple of the angle here is 1. So the angle to the right is multiplied by 2. The multiple here for the angle is 8. Yeah. If this angle is 8, if I multiply this angle by 8, then I'll get sine squared 8x. I have to do the same thing to this side. Multiply the angle by 8 cosine 16x over 2. So instead of having sine squared 8x, I'm going to replace it with 1 minus cosine 16x divided by 2. And let me just explain this again. Sine squared of x alone, or sine squared of theta alone, is equal to 1 minus cosine 2 theta. So basically, this angle is multiplied by 2 here. The angle is twice here. So if I multiply this angle by anything, say 8, then I also have to multiply this angle by 8. And what do you know, when I multiply it by 8, I end up with what I need to represent without any exponent higher than 1. So that's what I have squared. I can still simplify this. When I use the expansion, remember a minus b squared is equal to a squared minus 2ab plus b squared. So when I use that, I'm going to first take the half outside and square it on its own. So I have a quarter waiting for me after the end of all of this. So I'm basically squaring 1 minus cosine 16x squared, right? That is going to be, again, don't forget the quarter. And how did you get the quarter? Is you squared the denominator, which was the 2. That's how you got the quarter. So when I square 1 minus cosine 16x, I'll have 1 using this using this expansion rule. 1 minus twice cosine 16x plus cosine 16x, cosine squared 16x. Now going back to the reduction formula for cosine, it says that cosine squared x is equal to 1 plus cosine 2x divided by 2. It's over here. 1 plus cosine 2x over 2. That's what I'm using. Now, since I have a 16 here, I'm going to multiply this angle by 16. The angle. So multiplying the angle alone by 16, then I have 1 plus cosine 2 times 16 is 32x divided by 2. So instead of having cosine squared 16x here, I'm just going to replace it with this expression. So remember, I have a quarter outside. 1 minus 2 cosine 16x plus, instead of cosine squared 16x, I'll replace it with 1 plus cosine 32x divided by 2. I can simplify this. If I want. If you're feeling too lazy, I will not penalize you for leaving it where it is, but it's possible to simplify it, so I'm going to do it. I'm going to simplify. I'm going to bring a quarter inside. Or let me first break down this. A quarter into 1 minus 2 cosine 16x plus, this will be 1 over 2 plus cosine 32x over 2. So when I bring the quarter inside, that will be 1 quarter minus cosine 16x over 2 plus 1/8 plus cosine 32x over 8. I hope you can see that the initial expression had a big power of 4, and the final expression has a highest power of 1. All the powers of the final expression are 1. So I've basically reduced this expression into that, but it's the same thing. So, and you can prove this by plugging this into a calculator. Pick x to be any angle and then see what you get for this. Test it to see if it's the same thing you get for the reduced expression. Alright, find the exact value of a sine 2x, b cosine 2x, and c tangent 2x without solving for x. Now they've told us that x is negative 8. Sorry, tan of x is negative 8. Imagine I have a right angled triangle in which this angle is x. I know tangent is opposite over adjacent. So the opposite is 8. The adjacent is 1. I'm just going to use this negative to guide me on, to help me represent the quadrant. Because it's in quadrant 4, I know tangent will be negative. So I won't call my opposite negative. If I'm trying to be strict in, drawing it in the correct quadrant and drawing it correctly, then I will draw it like this. In this fourth quadrant, the angle would be here. The opposite would be negative 8 because it's going down in the in the y direction. This is x and this is y. The vertical axis is y, the horizontal axis is x. So since it's negative, it's going down in the vertical axis, that's why it's negative 8. The x direction will be 1. If I use Pythagoras, I can find the value of the hypotenuse. Pythagoras, I have 1 squared plus negative 8 squared, which is the same thing as positive 8 squared. Square root gives me the value of c. So when I simplify that, I will get c is the square root of 65. So this is c, the square root of 65. Now, from that triangle, the sine of x, because remember, this angle here, that angle is x. The sine of x from that triangle is negative 8 over 65 square root, and the cosine of 8, the cosine of x is positive 1 divided by the square root of 65. So this is still consistent because cosine is positive and sine is negative. So I can figure out what sine of 2x is and what cosine of 2x is. I know the double angle formula for sine of 2x is 2 sine x cosine x. So I'm just going to substitute for sine and cosine. 2 times sine of x is negative 8 divided by 65 square root, and cosine of x is positive 1 divided by 65 square root. If I simplify this, this will be negative 16 divided by square root 65 times square root of 65 is the same thing as just 65. So it's the sine of 2 theta. What about the cosine of 2 theta or 2x? Check this out. Let me hide it up there. Oops. Reduce. Yep, good job. Hide it up there. Okay. Put this down so you can see. Now I'm going to try and find the cosine of 2x. Cosine of 2x, remember, can be stated in 3 different ways. Let me just do it on a new screen. New screen. Cosine of 2x can be written in 3 different ways. You can write it as cosine squared x minus sine squared x. You can write it as 2 cosine squared x minus 1. You can also write it as 1 minus 2 sine squared x. I'm going to do all 3 just to show you that it gives you the same thing. Cosine squared x, cosine x is 1 over square root 65 from my triangle. I'm squaring that. Sine of x is 8 over square root 65 from the triangle. I'm just squaring that. Okay. So this one will give you 1 over the square root of 65 squared is just 65. And 8 squared is 64 divided by 65. So 1 over 65 minus 64 over 65 is negative 63 over 65. Let's see if this one is also equal to the same thing. I'm going to do this in a different color. I'll do this in blue. This will be 2 times cosine squared x is 1 over 65 square root squared minus 1. So this is 2 divided by 65 minus 1, and basically 1 is the same as 65 over 65, which would still give me negative 63 over 65. I'll do the last one in black. Blue, black looks like blue. Green. Okay, 1 minus 2 sine 65 is negative 8 out of 65 square root, but I am squaring that. So it's 1 minus 2 times 64 over 65. 2 times 64 is 128 over 65. So this is basically 65 over 65 minus 128 over, wait, is it 128? 64 times 2 is 128, yes, over 65. So when I subtract that, I should get negative 63 over 65. This was just to show you that it gives you the same thing no matter which expression for cosine 2x you use. So whichever one you choose, you're going to get the same thing. I forgot to do tangent 2x. Yeah, but you guys can do that. Just substitute it in the double angle formula for tangent 2x, right? And then you'll get the answer. Alright, in this triangle, they want us to find the half angle values for sine, cosine, and tan. Oops. AirPods.